Want to know the one set of formulas that could give you an instant 6-8 mark jump in your next physics exam? Give me a few minutes and I'll make Newton's laws so clear you'll never forget them and you'll definitely ace your exam. So it's Newton's first law of motion. There are 3 laws of motion given by the Newton. The first one is also known as law of inertia. Obviously I'll be explaining you what is inertia, but let me see what this law is about. So statement says an object will remain at rest or continue to move at a constant speed in a straight line unless acted upon by an unbalanced external force. That means if there is an object which is at rest, say for example there is a ball and it's lying on the table resting. If you will not apply any sort of external force to it, it will remain to be in a state of rest. It will not move by its own. There has to be some external force acting on it, any sort of external force. Or if I say that there is a ball already rolling on the floor and it will eventually stop, it will stop only if some kind of resistance is basically a negative force which works in opposite direction of the motion of something. That means if I'm running in forward direction, then the friction will work in opposite direction, will try to stop me. So if, say for example, if there is a ball which is already rolling, in that case, if whether it's a frictional force or the air resistance or any kind of opposite negative force will try to stop it, then only the ball will stop. Else it will continue. If I say an entirely frictionless surface, if there is, which is not possible to be all, but say for example, if it's on a frictionless table or frictionless floor and there's no air resistance, then we can say the ball, and if I push it, then it will keep on rolling infinitely as there's no other external force to stop it. So that's the meaning of the first law of motion, which says that any body which is in a state of rest will continue to be in a state of rest, or if it's moving will continue to be in a state of motion until unless acted by an external force. So example I have already explained you. So from here we get to know the term that's called inertia. Inertia is basically the tendency of an object or the property of an object, because in our whole universe this is very common. If we try to change something, the first instinct of even a non-living object is to try to stop that change, try to resist that change. So same thing is happening here. This is basically the property of an object which tries to stop or resist any change in a state of rest or motion. So that's that I have explained in first law. That means a body will continue to be in rest or continue to be in motion if you will not apply any force. That means this is the tendency of an object which is actually resisting a change. So here I have written the definition of inertia right here, which says inertia is a tendency of an object to resist any change in its state of rest or motion in a straight line unless acted upon by an external force. And obviously inertia is explained by the Newton's first law of motion, and this is the reason Newton's first law of motion is also known as law of inertia. Now inertias are of 3 types, but 2 types are in your syllabus. The third one, which is inertia of direction, is not in your syllabus. It's not mentioned anywhere. So this is the sole reason I haven't mentioned here as well. So we are talking about only inertia of rest and inertia of motion. Inertia of rest says in the tendency of an object to remain at rest until a force is applied. So if an object is at rest, it will continue to be in a state of rest. Take an example, a book lying on a table, and it will stays in that position until you push it. So that's called inertia of rest. And inertia of motion, that means if the object is in motion, continuous motion, and if there is no external force acting on it, it will continue to be in that motion. That's called inertia of motion. So here I have written the tendency of moving object to keep moving at the same speed and in the same direction until a force acts on it. Now example is a passenger in a moving bus is thrown forward when the bus stops suddenly. Now let me explain you why this happens actually. Now take this example. Suppose this is a bus seat like this, when this starts to move. So what will happen, that this is already moving, and so does your upper part is moving, and suddenly the bus stops, so this got stopped. But because of the inertia of the motion, the upper body continues to be in a state of motion for a while, and that's why what will happen, that this is moving in like this part has stopped, but this is moving, and this is the reason you fall forward. Now the second law of Newton says, that is also known as law of acceleration. So it says the acceleration of an object is directly proportional to the net force acting on it and the mass, but it's not directly, to be honest. Its mass is, if I say acceleration is directly proportional to the force and acceleration is inversely proportional to the mass. Or we can say that force is more appropriate way of saying is force is directly proportional to the acceleration and force is directly proportional to the mass. So if I combine them together, this will be force is directly proportional to m times a, or that can be written as F is equals to ma. So the more precise statement would be that acceleration or the force of a body is directly proportional to the acceleration. And then when we remove the proportionality, generally we introduce a constant. So in this case it's the mass, so F is equals to ma. Whereas F is force, and force has a very basic definition, that is pull or push is called force, which is in newtons. Acceleration is in meters per second squared. Acceleration is what? The change in velocity over time, how fast you are changing the velocity. If throughout the I'm saying like throughout the journey, if your acceleration, if your speed is same, then we can't say you are accelerating. Obviously after these three laws, I have that section where I have already explained the acceleration, but here also I'm explaining it, that when you keep on changing your velocity over the period of time, that's called acceleration, and its unit is in meters per second squared and mass is in kg. So these are all our standard units. So that means it's very simple, that larger the force, larger will be the acceleration. Larger the force, larger will be the acceleration, and the vice versa. That means if it would be lower, then the lower acceleration is there. So example is when you are pushing a shopping trolley that is empty, right? It's very easier because there is no mass in this case. So it's very easier to, you can say, push it and to make it, or you can say simply try to understand this thing, that suppose there is an empty trolley and you have applied the same force, say for example 20 Newton, you will be able to accelerate it very quickly. Whereas if it's loaded heavily, mass has increased, in that case acceleration taken by the trolley will not remain same if you are going to apply the same Newton force. If it still is 20 newtons, then it will not accelerate to that high acceleration as it was previously when the trolley was empty. So that's because of its direct relationship. Force is directly proportional to the mass and force is directly proportional to the acceleration, which makes acceleration inversely proportional to the mass. That means if I keep my force same, whenever we keep something same, it converts to proportionality. That means F is equals to ma. I have kept my force constant. That means I can write A is equals to F over m. Because I have kept my force constant, that shows that this will remain constant and A is inversely proportional to the mass. So when I'm applying 20 Newton of force, because in both the cases the forces is still the constant, and that's why I can say acceleration is inversely proportional to the mass. Higher be the mass, lower will be the acceleration. Lower is the mass, higher be the acceleration. Similarly, if I say that a body has a constant acceleration, in that case F is directly proportional to the mass. That means if you want, there are two different bodies. One body is of 10 kg and another body is, let's say, 20 kg, and you want both of them to accelerate constantly with 2 meter per second squared. You want both of them to be at same constant. So when acceleration is constant, so now this equals to will convert into proportional, and F is directly proportional to the mass. That means I have to increase my force if the mass is greater, I have to decrease my force if mass is lesser. So for 20 kg of mass, I have to apply more force in order to accelerate it at 2 meters per second squared, whereas for 10 kg, I have to apply comparatively lesser force as compared to the 20 kg mass. So that's the second law of motion, which is also known as law of acceleration. So what we get from second law of motion is acceleration, or most importantly is the force that we get, and this is the reason that the unit of force is newtons. Now Newton's third law of motion, which is, I can say, the most famous one, that says for every action there is an equal and opposite reaction. So when one body exerts a force on another body, the second body exerts an equal and the opposite force. That means if you are pushing a wall, then wall will also exert the same amount of force on your hand. Now take an example. When a swimmer pushes against the pool wall with his feet, the wall pushes back with an equal and opposite force. So basically wall pushes him in forward and pushing swimmer in the forward direction. So what it's happening is basically, so same amount of force is exerted on the wall, and wall has exerted in back, not in backward direction, pushes back. That means like has given an opposite reaction to the swimmer, and thus helping him in pushing in forward direction. So an initial push is very important for the swim, so that the swimmer is getting from this wall. Now, as I told you, I have explained what is an acceleration after these three laws of motion, which is here. Acceleration is rate of change of velocity over the period of time. That means when you keep on changing your velocity over a period of time, suppose your speed first is, let's say, 2 meters per second, then you have changed it to 10 meters per second, then you have increased a little bit and made it 15 meters per second, and you have reached to 20 meters per second. You can clearly see throughout your journey you keep on changing your velocity, and practically it's not possible to keep your speed constant. If you're driving, obviously it's not possible. So you are accelerating because over the period of time you are changing it. Now acceleration is also written as acceleration or deacceleration. Acceleration is basically a vector quantity, and this is the reason we write it as in positive and a negative. So when I'm talking about specifically acceleration, that means it's accelerating, it's increasing. When you keep on increasing the velocity over a certain period of time, that's called accelerating. Whereas, say for example, your velocity is 20 meters per second, then you have lowered it down to 16, then lowered it down to 8, and then 2 meters per second. So what's happening here? You're constantly decreasing your velocity, so that's called deacceleration, and your answer will be a negative. The negative value defines that this is decreasing. In case of displacement, if I'm saying 20 meters, so that means I'm moving in forward direction. Minus 20, that means in opposite direction I'm moving. So similarly here also the negative represents that your acceleration is actually decreasing. You are decreasing the velocity and you are just coming to a zero. Ultimately you are going to finally stop. And the formula to calculate acceleration is change in velocity over time. That's acceleration is change in velocity over time. And change in velocity is final velocity minus initial velocity over time. So that is final velocity minus initial velocity over time. And that's called acceleration. Its unit is meters per second squared. It's very easy to derive its unit because it's change in velocity. What's the unit of velocity? Meters per second. And time is already in seconds, so you'll get meter per second squared. Now let me see the equations of motion. Don't get confused, these are not the Newton's equations of motion. They are just equations of motion. Laws are actually given by the Newton. So these equations of motion deals with few quantities, few parameters. They are displacement, which we represent in S. It's very important. So displacement is represented in S, which is always in meters. And if it in question it's not in meters, you are supposed to convert it. Second is initial velocity, which will represent with U, which is in meters per second. Final velocity is V. We represent final velocity in V, which is meter per second, and acceleration as A, which is meter per second squared, and time for an object in seconds. So time is t and it's in seconds. So let me see the first equation of motion, which is V is equals to U plus AT. Whereas I have already explained you, V is final velocity, U is initial velocity, A is acceleration, and T is time. That means, say for example, in a question, you have time, acceleration, initial velocity given, and they are asking you to calculate final velocity. See, all these have the same repeating parameters V, U, S, T. But you have to apply these equations according to the question. See this one. It says a car is starting here. So very first thing, while doing these questions, I will suggest you to write down what all parameters are given. That will definitely help you in understanding which equation of motion you have to apply. So a car is starting from rest. Whenever it's mentioned that something is starting from rest, that means their initial velocity is 0. Initially it was at rest, so that's 0. Initial velocity is U, which is 0. Now accelerates for 5 seconds. Time is given as 5. And attains a velocity of 10. Finally it attained the velocity. That means that's your final velocity, which is 10 meters per second. Calculate the acceleration. Obviously, we have this one easily. You haven't studied the two other equations of motion yet. I haven't explained it, but still, even after that, you get to know that the only equation which has these all parameters is just the first equation of motion. Apply this one. So V is equals to U plus AT. So now substituting value, V is already given as 10, U is 0, A is A, and T is 5. So from here, 5A is equals to 10 and A is equals to 2 meter per second squared, which is this one. Now second equation of motion is here. In the first equation of motion, there is no displacement, whereas in second equation of motion, there is. So it says S is equals to ut plus half at squared, where S is displacement in meters, U is initial velocity, T is time, A is acceleration. So let me take an example. A car is moving with a velocity of 20 meters per second. I'm again saying, whenever you are doing any question, not necessarily on this one, any sort of numerical question, you first thing you have to do is write down the data. That's most important thing. So it's initially moving with a velocity of 20 meters per second. So let's say u be 20. Accelerates at 3 meters per second squared, so acceleration is 3, and units are very important. They all have to be in standard units. Keep checking these. I can see they all are. Now for 10 seconds, t is equals to 10. Now calculate the distance covered during this time. Now they are asking distance. Whenever distance or displacement they are asking, obviously your first equation of motion will be cut out. Obviously we don't need them, as there is no main displacement or distance given in it. So second and third equation does have it. In this case we do have time as well, so obviously I'll use this one. S is equals to ut, which is 20 times 10 plus half at squared, so half times 3 times 100, t squared 100. This is 200 and plus 150 will give me 350 meters, this one. So we can clearly find the displacement. Now moving on to our third and the last equation of motion, which is v squared is equals to u squared plus 2as. V is final velocity, u is initial velocity, a acceleration, and S displacement. As I told you, displacement is in third equation of motion as well, but it misses time. So if displacement and time combination is there, obviously you have to choose 2, and if it's free from time and you have to find displacement, or displacement is given, just choose 3. So it's very easy to choose equations of motion. Now calculate the distance covered by a body when the body started its journey from rest. That means initial velocity is u. Attained a velocity of 10, that is final velocity is 10, acceleration is 2, and they're asking you to calculate displacement. No time is given, so I'll choose third one, which is v squared is equals to u squared plus 2as. This is 100, v squared, u is 0, 2, acceleration is 2, displacement s. 100 is equals to 4s, and s is equals to 25 meters. So this is how we can apply these in this section, because it was all the theory section. So I'm not doing any further harder questions that we will be doing when we'll be doing the worksheet. So that's it for today in this. And also, if you're looking for one-on-one live online classes for GCSEs, they are starting at £6 per hour. We provide both one-on-one and group classes. So rates are according to it. And if you're looking for free worksheets, they are available. This worksheet, or these theory sheets or worksheets or the cheat sheets, if you're looking for that, they all are available at exacademy.com. And if you want to enroll, you can just email us to book your free. Obviously the demo is free of cost, so your free demo, for that all you need to do is just email us at exactacademy@gmail.com, and we coordinate accordingly. So it's not only maths and physics that we provide classes for all subjects. So that's it for today, guys. Bye everyone, take care.